where I'm going to be explaining each of them one after the other, and we solve one or two examples on them. Now the first property is closure property. I promise you that I'm going to explain the closure property when we move to the next slide. So what is meant by closure? Set is closed if applying the operation keeps you in that set. What's the meaning of this? When you are given two sets, like the example, I'll solve the example like that in the former slide. When we have, let me give you an example now. When you have A operation B equals to A plus B, and you are given two numbers like this. Look at this example. Z is closed under addition. So when you are given 2 operation 5, it will give us, according to the definition of this operation, it is supposed to give us what? 2 plus 5. That is what? 7. Now we have been given a condition here. This is the sets. The sets. What is the meaning of this Z? Z means set of integers. And what are integers? Integers are set of positive and negative whole numbers. Set of positive and negative whole numbers. So after we add 2 plus 3 and we have 7. 7 is also an element of an integer. 7 is also an element of an integer. So that means the set is closed. It is closed when, after applying the operation, the number that you get, the result that you get, is still a member of that set. So the set you are given here is integers. So, and the answer that we get here is 7. 7 is also an element of an integer. So, and it is not like this always for all operations that we have in mathematics. Now look at this second example. N is what? Natural numbers. And what are natural numbers? Natural numbers start from what? 1, 2, 3 to infinity. So now the example is now stating that natural numbers are not closed under subtraction. Let's check that. So what are natural numbers? We say natural numbers are numbers that start from what? 1, 2, 3, 4, and so on. Now, if you are using the formal operation that we have, that A operation B is equal to A is equal to A minus B. Let's see, that's the operation. So for this one to be closed, it means any number that we pick from a natural numbers and we perform this operation on it, the answer we must get must also be a natural number. So now let's pick 2 numbers from natural numbers. 3 is the natural numbers. 5 too is the natural number. Forget about what is in between them. So now let's say we have 3 operation 5. 3 operation 5 according to this operation that we are given here. We got 3 minus 5. And what is 3 minus 5? Minus 2. Minus 2 is not an element of what? Natural numbers. So minus 2 is not an element of natural numbers. You know, natural numbers start from 1, 2, and so on. So minus 2 is not, you cannot find minus 2 in natural numbers because it starts from positive 1, no negative energy, always positive. So that is that on closure. Anytime you are given an operation, after performing the operation on that number, the result you must get must also be an element of that set you are given. So in most cases, they will give you the sets. Maybe you will see set of real numbers, set of integers, set of whole number, set of natural numbers, and they may even give you the number of set inside that particular set. So let's move to the next slide. So as we are saying, still on closure property, as we have recently defined closure property as a binary operation on set S, that it is closed if A and B in S also give us a result that is in S. So example of that is this. So let's just assume that what we are given here, let's assume that A and B that we are given, A operation B is equal to A squared plus B. That is what the operation is defined as. So it means anywhere we see A, we put 3. Anywhere we see B, we put 4. So, but we are not given the condition here. We are not given whether the element we are given here is a natural number or a real number or rational number. So let's assume that we are dealing with natural numbers. So you know natural numbers start from 1. Natural numbers start from 1, 2, 3, and so on like that. So let's say the element we are given here, the 3 and 4 are elements of natural numbers. So after we now apply the operation, which is 3 operation 4, give us 3 square plus 4 equals to 3 square is 9, then plus 4, it gives us 13. So 13 that we have as the final result is also an element of natural numbers. So it means natural number is closed under addition. And addition is closed. This operation is closed under addition. The operation that we are given is closed under addition. Now let's look at another example. Example 2. If A operation B is equal to AB minus A. So we are asked to find 5 operation 3. So this, you know, I told you it could be represented by any sign. So the operation that is used here is star, but you won't call it A star B. It's A operation B. So it is defined as AB minus A. AB minus A. So it means anywhere you see A, you put 5. Anywhere you see B, you put 3. So now substitute the value. We have 5 operation 3. Will give us A is 5 and B is 3. So since it is written together as AB, so it means we are going to multiply it. It will be A times B. So A times B means 5 times 3 minus the value of A is 5. So 3 times 5 gives us 15 minus 5. That is 10. So you can now check this example to practice. But out of all the example we are given here, the only one that I see that may give you a tough time is that number 4. They said determine whether subtraction is close on integers. So you can use any of the operation to determine that. So I will do the number 4. That number 4, we are to determine whether subtraction is close on integers. What are integers? Integers are positive and negative whole numbers. So integers start from minus infinity. Let's say minus infinity, minus 1, 0, 1, 2 to infinity. So this is minus 1, minus 1. Now, if you want to use that, just pick any of the operation here. Let's use that number 2. Let's say we have, okay, let's pick another one offhand. Let's say A operation B is equal to A minus B. And A is an element. A and B are elements of integers. So we want to check whether subtraction is closed, whether after applying this operation, the result we are going to get will still fall under integers. So let's say we want to find 3 operation 7. So it means the value of our A is 3. So we have 3 operation 7 will give us what? 3 minus 7. What is 3 minus 7? That gives us minus 4. The minus 4 that we get now, is it an element of integers or not? It is an element of integers because integers are positive and negative whole number. So of which minus 4 is also an element of integers. Minus 4 is also an element of integers. So I told you the sign of integers is Z. So you have to practice number 1, number 2, number 3, and number 5. That is on closure. Take note of that. So we now moving to commutativity. So commutativity is an operation. An operation is commutative if A operation B is equal to B operation A. That is, when you have 2, so when you have 2 multiplied by 3 is the same thing as 3 multiplied by 2. When we have such equation like this, we say they are commutative. So addition 2 is commutative because when you have 2 plus 3 is the same thing as 3 plus 2. But subtraction is not commutative. because 2 minus 3 is not equal to 3 minus 2. So commutativity doesn't apply on subtraction. So, but when you have multiplication and addition, it could be commutative. So let's look at this example. Look at this example. When we have 3 operation 5. 3 operation 5. 3 operation 5 equals to 8. So that means they have defined the operation for us already. So that means the operation we are given is A operation 5. Okay, sorry. A operation B. A operation B is equal to A plus B. That's the operation we are given. A operation B is equal to A plus B. So when we now have 3 operation 5, it will give us 3 plus 5. That is equal to 8. Now, 5 operation 3 is also equal to 5 plus 3, which is equal to 8. You can see that 3 operation 5 is equal to 5 operation 3. So both of them are commutative because they give us the same value. That is commutative property. Take note of that as we move to the next slide. The next slide is associativity. Associativity is an operation when an operation an operation okay, let me use up there. An operation is associative is associative if A operation B into brackets operation C is equal to A operation B into brackets operation C. So when we have this type of condition, we say they are associative. So example of that is when you have 2 plus 3 plus 4. Let's say we have 2 plus 3 plus 4. So if you now pick it, you first pick 2 and 3 first plus 4. That is one condition, which is A operation B operation C. That's 2 plus 3 into bracket plus 4. If it is the same thing as 2 into bracket 3 plus 4, then we say it is associative. So now we are moving to the next slide. Identity elements. What is meant by identity elements? Just like as we have in matrices. You know, in matrices, when you call something an identity, it's always in this form. When you have something like this, 1 1 0 0. So in matrices, if you multiply any matrix with this particular matrix, you will get the same value for that matrix. So also, when you multiply a number by 1, you get the same value for that number. So 1 is an identity element for this multiplication because it's not changing the value of that number. So anytime you are looking for identity of a number, it is always in this form. Whenever you multiply that number, so here is represented by E. E is identity. If A multiplied by A operation E is equal to E operation A, which is equal to that same A. So it's like we are multiplying a number by another number that will not change the value of that number. So which is 1. So example, 0 is an identity for addition, while 1 is an identity for multiplication. The identity for addition is 0. Any number that you add 0 to 5 plus 0 could still give you 5 plus 0, then 0 plus 5 will still give you 5. That is all about identity element. So 0 is identity element for addition. And then for multiplication, when you have 5 multiplied by 1, is the same thing as 1 multiplied by 5, and it will still give you what? 5. So A multiplied by an identity element equals to identity element multiplied by A will give you that A. That's what is meant by identity elements. Now look at this example. A operation B is equal to A plus 2B. They said identity element of this one is 0. So what does that one means? It means when you add and you say elements. So, but what identity means is any number that you multiply or you add to another number and it will still give you the same value. Like if you are asked to find the identity elements of 5 is 0, because if it is divine on addition, it will be 0. If it is divine on multiplication, it will be 1. So now let's move to the next slide. The next slide is the inverse. So as we all know, the meaning of inverse means the reciprocal. When you have 5, the inverse of 5 is 1 over 5. So B is inverse if A operation B is equal to A. What that means is when you have A operation B is equal to identity element, that means the value of this B will give you the inverse. Look at the example that we have there. Operation with identity O. Inverse of 5 is minus 5. How do we get minus 5? We have been told that when the inverse